My dear students, in this video, I am going to continue the introduction of vector product or cross product. In the previous video, I have defined the definition of vector product and I have given you how to find out the unit vector n cap, formula for finding the unit vector n cap, and angle between the two vectors A and B, that is theta, and some more properties we have seen. Now in this video, I am going to find out the area of the triangle formed by the two vectors A and B as the adjacent side of the triangle. You consider this is a triangle ABC. AB along the side AB, the vector A is acting along the side AB, and AC is vector B. AC vector is B vector and AB vector is A vector, and theta is the angle between the two vectors A and B. The area of the triangle ABC we have to find out now. Area of the triangle ABC, you know, area of the triangle ABC is half base into height. Suppose you consider the height of the triangle. By CD. Area of the triangle is half base into height, you know. Half into AB into CD. This is the formula for finding the area of the triangle by geometric method. Geometrically, we can determine the area of the triangle is half into AB into CD and half base into height, I mean. Theta is the angle between the vectors A and B. Now, what is CD? In the triangle ACD, CD is a sin theta is opposite side by hypotenuse. You know, sin theta equal to opposite side CD by hypotenuse AC. AC is nothing but mod of B vector. Therefore, CD is mod B into sin theta, you know. From this, I can write it as CD is mod B into sin theta. So this is CD, modulus of vector B into sin theta. So that is half into AB is mod of AB into CD is mod B into sin theta, and mod AB is mod of A vector. This is mod A into mod B into sin theta. So that is equal to half into mod A into mod B into sin theta is by definition mod of A cross B. Mod of A cross B is mod A into mod B into sin theta. N cap, modulus of n cap is 1, so you need not write 1 here. Therefore, mod of A cross B. This is nothing but mod of A cross B. A vector is AB vector into B vector is AC vector. Of mod AB cross AC is the area of the triangle formed by the sides of AB and AC having vectors A vector and B vector as the adjacent sides of the triangle. And theta is the angle between the vectors A and B. So area of the triangle is half into mod of AB cross AC. This is our idea. So any two sides are represented by a two vector, then A cross B divided by 2 is the area of the triangle. Vector area of the triangle is, this is the area of the triangle. Vector area of the triangle is you just half into, not modulus, you just write AB cross AC. Half of AB cross AC, vector product. This is vector area, this is magnitude of the area. Next, one more idea. Area of the parallelogram having A vector and B vector as adjacent sides. Area of the parallelogram having A vector and B vector as adjacent sides. Next idea is the area of the parallelogram. Area of the parallelogram ABCD. That means this is A, B, C, D. This is parallelogram ABCD having adjacent sides. AB is vector A and CD, AD is vector B, and this is our angle between the two vectors A and B, that is theta. Okay. This angle between the two vectors A and B is theta. Here also, if you draw a perpendicular from the opposite vertex to the base, DE you know. Here D is mod B sin theta you know. So, area of the parallelogram is nothing but base into height. Base is AB, into height is D. The AB is mod of AB, that is mod of AB vector. This is D is mod of DE vector. That is nothing but mod of AB is A vector. You just write it as AB itself. Mod of DE is mod B sin theta. That is nothing but mod of B. Height is DE. D is mod B sin theta. AB is mod A into mod B into sin theta. AB is mod A. Therefore, this is nothing but simply mod of A cross B. So, area of the parallelogram is just mod A cross B. Area of the triangle is half of A cross B. This is area of the parallelogram is half of A vector is AB vector, B vector is AD vector. Area of the parallelogram, cross product of area of the parallelogram having adjacent sides A and B. That's adjacent sides. Vectors A and B are two adjacent sides of the parallelogram because area of the triangle is, half of AB cross AC. This is, if you divide this parallelogram into two triangles, that's why it is called, that's why it is just determining the 2 times of half area of the triangles. You have two triangles. Area of the parallelogram consisting of two triangles, therefore half AB cross AC is 2 times of half AB cross AD, or you just consider this as by C AB cross AC. Okay. Suppose AD cross AD adjacent sides. Okay. This is the area of the parallelogram. Next, area of the parallelogram is nothing but the modulus of magnitude of the vector product of the two adjacent sides of a parallelogram. This is area. Vector area is not just AB cross A, not modulus. Magnitude is area. If you are removing the magnitude, that gives you the vector area of the parallelogram. Just parallelogram is two triangles, one and two. Half AB cross AC, two times of half AB cross AC is just AB cross AC, like that. Suppose you consider this A, B, C and D. You consider the triangle. This is A, B, C. You know the area of the triangle is half mod AB cross AC. You know the area of the triangle is half AB cross AC. It is again another triangle of the same area. Therefore, you get two times of AB cross AC is the area of the parallelogram. This is area of the triangle. This is area of the parallelogram. This is area of the triangle. This is area of the parallelogram. Two times of half into 2 is just half AB cross AC. 2 into half is, you cancel just half AB cross AC, just AB cross AC. This is area of the parallelogram. Now, cross product of two vectors with its components. I am going to introduce now. Draw products of two vectors with its components. Sorry, cross product. Draw product, I believe you know. I dot I1, K dot J1, K dot K1. If the two vectors are interchanged, I dot J 0. Okay, now cross product of two vectors with its components. Suppose A is a vector given by A1I plus A2J plus A3K. B vector is given by B1I plus B2J plus B3K. What is A cross B? A cross B is A1I plus A2J plus A3K cross. B vector is B1I plus B2J plus B3K. Just first you get A1 with all three rest of the terms. A1 B1 into I cross I. A1 B1 into I cross I. What is I cross I? 0. Similarly, A1 B2 into I cross J plus A1 B3 into I cross K and plus A2 B1 into J cross I plus A2 B2 into J cross J plus A2 B3 into J cross K. plus A3B1 into K cross I plus A3B2 into K cross J plus A3B3 into K cross K. Like that you have to split A1B1 into I cross I, A1B2 into I cross J, A1B3 into I cross K, A2B1 into J cross I, A2B2 into J cross J, A2B3 into J cross K, and A3B1 into K cross I, A3B2 into K cross J, and A3B3 into K cross K. You know I cross I 0. I cross I is 0. You know already. I cross I, J cross J, K cross K, everything is 0. And clockwise sense, I cross J is K, J cross K is I cross J cross K cross I is J. Reverse is J cross I is minus K. So first term is I cross I 0, I cross J, K. Therefore, next term is A1 B2 into K vector. I cross J is K. And A3 B3 I cross K is minus J. Therefore, minus of A1 B3 into J cross I cross K is minus J. Therefore, it becomes minus. It is minus J. And similarly, J cross I is I cross J cross I is minus K. Therefore, this is also minus A2B1 into K. J cross I is minus K. And J cross J is 0. And J cross K I plus A2B3 into I. J cross K I. And similarly, A3B1 into K cross I J. So A3B1 into K cross I J, K cross J, J cross K I, K cross J minus I. Therefore, this is minus A3B2 into K cross J minus I. Therefore, this is minus I. And K cross K is 0. That's all about the term. Therefore, what do you get? Items, you get two items. What is that? A2B3 minus A3B2 into I vector. A2B3 minus A3B2 into I vector minus J. A1B3 I am taking minus out, therefore minus A3B1 into J vector. Minus, if I take common A1B3J, if I take minus A3B1 into J, okay, plus K times A1B2 minus A2B1 into K. See, this is the cross product of A and B, A cross B. This expansion is nothing but the determinant value of ijk having first row, second row A1, B1, sorry, A1, A2, A3, B1, B2, B3, and so we will see this is nothing but cross product of two vectors with its components. In terms of its components is see, I can simply you call this as determinant I, J, K, A1, A2, A3, B1, B2, B3. This is the value of A cross B if its components are given. This is A cross B. Because this expansion is we have derived from A cross B. Expanding the determinant, you will see I vector into A2B3 minus A3B2, A2B3 minus A3B2, A2B3 minus A3B2, you know the expansion determinant, minus J vector into A1B3 minus A3B1, A1B3 minus A3B1, plus K vector into A1B2 minus A2B1, A1B2 minus A2B1. See, these two are one and the same. A2B3 minus A3B2 into I minus A1B3 minus A3B1 into J plus A1B2 minus A2B1 into K vector. Therefore, A cross B its components is nothing but the determinant value of I, J, K, A1, A2, A3, B1, B2, B3 and K1, C2, A1, A2, A3. So, A cross B is nothing but if its components are given, A cross B is determinant value of I, J, K, A1, A2, A3, B1, B2, B3. This is the expression for the cross product of two vectors in terms of its components. That's all about the idea. I will stop here and we will continue in the next video. Thank you.